Today, Mr. Greg Moser of FuturePlus is going to demonstrate the FS4500 DisplayPort Protocol Analyzer on a 4K display.
Today I'm going to demonstrate the capabilities of the FS4500 DisplayPort Protocol Analyzer from FuturePlus systems. To begin with, our Probe Manager that comes with the product allows you to select different protocols from DP 1.2 to EDP 1.4. We can do SST as well as MST in 1.4. Today I'm going to show you on a system running 1.4 SST. I've got a 4K panel attached, and I will show you the benefits of our tool. Along with the main link, we can also capture aux. We can also trigger from aux and cause the main link to trigger. So this is helpful when you're trying to capture the training patterns. So I'm going to leave it in main link for now. I'm going to select 1.4 SST. Then I can configure the tool. Currently I'm using our FS1046 DisplayPort repeater, and I'm running on a 4K panel and running at 5.4 gig. We also support FEC and DSC. However, we do not have that on this system, so I'm going to leave that disabled for now. We also support ASSR for when we're running EDP. We support 10D mode as well. Our trigger consists of several different types of triggering capabilities. We can trigger on one event. We can trigger on two separate events, so we can have an event look for one particular trigger and the second event look for another trigger, so whichever one occurs first will cause the machine to trigger and capture data. We also can look for one event followed by another, so that it would wait for the first event to occur. Say I was looking for an MSA, and then I was looking for BS, so it would wait for the MSA, and then once it saw the BS, it would then trigger and fill memory. We also can accept a trigger, an external trigger, to our box, either triggering on a falling edge or a rising edge, and we can also trigger out to another device through a coax cable. And the cross-link trigger is for the aux to the main link. You can also trigger on lane data. You can also select a K character and choose the K character you want to trigger on. You can select, one lane or all 4 lanes if you want. We have the capability of capturing up to 1 gigastates. We can move the trigger position, so we can either trigger at the beginning, so the trigger would be at the beginning of the trace file, and we would have more post-store. This type of trigger is helpful when you're trying to capture as many frames as you possibly can. You could have the trigger position at the front, trigger on an MSA, and through filtering, you can capture several frames in a row. You can also choose to have the trigger at the end of the trace, which gives you pre-store. I'm going to set it right in the middle for now, and I'm going to change my memory depth back to 8K. So right now I'm going to set up a trigger to trigger on an MSA. And all I have to do is, because I've already set up the number of lanes and the speed, I'm going to click Run. And there's a little bar up here that'll tell you what's going on. I'm going to look at my listing window. So here you can see that we have captured the MSA. Our pixels, horizontal pixels, 4,000 pixels in width. So it's 3840 by 2160. So now you can see all the dummy data that we don't really want to capture because it's just taking up memory. So what we can do is we can go back to our Probe Manager, the filter, and let's say we want to get rid of the blanking dummy data. Just select that, take another trace, now you can see that this is the MSA that we trigger on. And we get the VBIDs occurring shortly after. And shortly after that, we get the beginning of the pixel states. So this pixel would be the first line in the upper left-hand corner. Now you can also choose to decode the pixels if we want. So we're set up for RGB, 24 bits per pixel, 4-lane width. So I'm going to select to decode the pixel states and apply that. So you can see right here we actually break down the 3 different components of each pixel and display what the value is. Now you notice there's some stuffed data symbols. If we want to get rid of that, we can certainly go right into our filter. We'll get rid of it. We'll go in there and select active video stuffed data symbols. Now when I run that, now all the active symbols, stuff symbols have been removed, and we're just left with data pixels. So if you want to capture many different frames, this is the best way of filtering. We can actually filter the VBIDs if you need more memory. So the nice thing about the filtering is it's a pre-filter. So it will actually provide you with more storage capability by filtering out things you don't need. We also have a summary, which will, we can select all the different traffic types, summarize the data, and it gives us a count of each pixel type. And over here on the right-hand side, you can see that we have a color code, which tells you what type of traffic is what color. So obviously the pixel data, there's a lot of pixel data here. We can also change it to a table, which will then give you the actual numbers of each traffic type. If you want, you can actually export this data to a CSV file. So if you want to actually take all the pixel information and run it through a tool of your own, you can possibly do that. If you want to create a program that will actually display all the frames sequentially, you could actually export this data to a CSV file and then import that into your piece of software. So another feature I want to point out is the aux capture. So the aux is very similar as far as you don't have to set the probe up because we've already done all that. However, we do have all the same types of triggering. We do have a memory depth just for the aux as well. Of course, generally there isn't too much going on in aux. So a lot of times, if we just have this set for a low value, that's plenty of capture. So I'm going to start by, I'm going to select an aux write. You can actually provide an address and data if you desire. And I'm going to click run. Now when I click run, it's going to sit and it's going to wait, and I'm going to have to go over to the target and actually do a unplug and replug. So it'll take just a minute here. So I'm going to get this running, and it's going to tell me it's waiting for the trigger. And you can see that it has triggered, but it hasn't completely filled because there's just not enough aux data to actually fill the buffer. So I'm going to stop this, and I'm going to go to my aux listing. And I'm going to add the listing. So as you can see, the trigger was an aux write, and we decode everything that's occurring on the aux link. And similar to the main link, we do have a summary here as well. And I'm going to run that, show the summary. So we can get the summary here, and this will give us basically how it's, some of the main attributes, how it's set up, you know, as far as the bandwidth, you know, it's 5.4 gigabits per second in the lane count. So just general information here. If you want to get more specific, you can actually select the address range. If you know a particular address range you want to look at, you can just select that and it'll display it right here. So this is very helpful, particularly in MST when you're trying to figure out the virtual channels and how they're assigned. That'll give you this information here. You don't have to look through the actual file itself. It's quick and easy to get what you're looking for. So now I'm going to demonstrate the aux to main link capture. So I need to set that to aux to main link. I'm going to actually go into the main link and increase the memory depth a little bit. And then I'm going to go back to my aux trigger. And this time I'm going to select an aux write to address 102. Actually, I'm going to do trigger 1, then trigger 2. And I'm going to repeat my trigger here because this can happen multiple times. And if it happens a second time, I want to capture that second aux write to this address. And so now what will happen is when this triggers at this address, it'll then trigger the main link and will capture main link data as well. So I'm going to run this, and then I'm going to unplug and replug again. So once again, it is triggered, and this is telling me the buffer is not completely filled. That would be, again, the aux buffer is not completely filled, so I'm going to stop this. We can look at the aux listing again. Let me go back to the listing window. So this is now the new captured trace. This is training pattern set. And you see the address right here, 102. And then I can go to my main link listing. And so this is right at the time of the trigger on the main link. So the main link hasn't even gotten into, hasn't quite gotten into the training yet. Okay, here you can see it go into training pattern 1. So what I can do is I can do a search. We have a search function, and I can search on event code, and I can look for training pattern 1. Going forward, and there it is. So that's where it's starting. You can see it's making its way. So where it says there's a mismatch, generally if there is a mismatch within the lane, you can see there's 2 BS symbols here. And because all 4 lanes do not match, that's why we're saying it's a lane mismatch. So if the link was already up and running and there were no errors prior to that, if you all of a sudden you got a mismatch on a symbol on one of the lanes, we would actually indicate that, and you can actually trigger on that type of error. You can see that eventually, we'll see if we captured the next training pattern. No, it doesn't look like it. No. If you wanted to capture more data further on, you could simply increase the buffer size in the main link. Going into the trigger, we could actually increase the size of that. Actually, what I should have done is change my trigger position so that way we would have had more post-store. In fact, I can try that. Let me increase this a little bit more, and I'll run this again. Okay, I'm going to stop this. And again, I can look for TPS1. There it is. If I captured that, there's TPS3. Okay, and now it's going into the idle pattern. You can see now it's going into the idle pattern. So you can keep increasing the memory until you get, the real data, more data coming through, the actual DisplayPort data. Another feature that we have is you can save this data out. So not only can you export it to a CSV file, you can actually save the configuration file with the data. You can send it to a colleague, or say you have a customer that you need to share data with. You can actually save this out, send them the Probe Manager. They can install the Probe Manager on their computer, and then they can load the data and actually look at it offline, just like we're looking at data here. We do also have a log file here, and if If we have the logging enabled, if there's an 8B, 10B error that occurs while the probe is running or capturing data, it will actually output that information here in the log file. And you can actually write that log file out to a text file if you want. So let me go back into, now I'm back on the main link. I select the main link again. And what I want to look at is the triggers. So as I had stated earlier, there are, you can select to trigger on any error. So if there is some 8B, 10B error, or some error that occurs that we identify, we can actually trigger on that. And so that's about everything that our probe will do. As I stated earlier, we do provide probing for many different options. EDP, we do have Type C capabilities. You can see right here, the Type C, we have a snooper and a repeater. The snooper basically is just a pass-through, and that's generally good up to about 5.4 gig. Once you go above 5.4, then you have to go to the repeater. But the repeater does not retime the signal, it just repeats the signal. So that will conclude our video, or our demonstration. I hope you found it helpful. Thank you.
Thanks, Greg. Probing for the FS4500 is available for regular DP, USB Type-C, and EDP. We also can help with custom configurations. For more information on this product, contact us and refer to our website at www.futureplus.com. And we'll see you next time in the lab.